Our next talk right now is navigating Open RAN lessons from working with large telcos. The presenter for this that I'd like to introduce is Keshaf Islam, and he will once again be presenting Open RAN lessons from working with large telcos. Keshaf is a principal architect at Red Hat and has traveled to us today from Raleigh, North Carolina to join us. This is Keshaf's first time presenting at NANOG, and it is a pleasure to have him speaking with us today. Welcome, Keshaf.
All right.
Here's your clicker.
Well, thank you for having me here. As we talked about, my name is Keshaf Islam, and I'm a principal architect at the Red Hat. And what I'm here for today is to share some of the lessons that we have learned over the last several years in terms of navigating, deploying, and also operating Open RAN. Our agenda is pretty simple. First, we'll talk a little bit about the Open RAN evolution, like how the RAN has evolved and where is it going, and we'll dig deep into the lessons themselves. All right, so to understand Open RAN, you need to actually understand the RAN triplets: the virtualized RAN, Cloud RAN, and Open RAN. Virtualized RAN is the first evolution that happened in probably 2015-16 timeframe, in which basically the RAN components were softwareized. So instead of deploying the RAN functions on the hardware and a physical function, you deploy them as a virtual machine on a generic x86 compute using commercial off-the-shelf hardware, so COTS servers, which obviously requires the use of a VM to run these components. And what you can consider the virtualized RAN to be as a superset of Cloud RAN or CRAN, which it is sometimes called. Now, we should not confuse Cloud RAN with centralized RAN. Two separate technologies, two separate architectures, orthogonal to one another. Now, in this evolution, the second evolution of virtualized RAN, which is the Cloud RAN, the RAN functions are not just softwareized, but they are also cloud native. Now, everybody means something different by what a cloud native function means, but to make it short, it's basically when you implement your functions as either containers and the microservices-based architectures. Once again, you shouldn't confuse Cloud RAN as a function which only runs on public cloud. You do not need to be on the public cloud to be cloud native. Because these functions are containerized, mostly, you would require some sort of a layer to run those containers and the workloads, which the industry has kind of standardized on Kubernetes. All right, so then we talk about Open RAN. Now, the Open RAN is neither Cloud RAN nor virtual RAN. It's not a technology. Rather, it's a movement to drive more openness into the RAN ecosystem. By openness, we mean the use of open architectures and open interfaces between various RAN components. And what you can consider Open RAN to be as an architecture that is orthogonal, but to both the virtualized RAN and Cloud RAN. Right? Open RAN movement is primarily driven by the industry and with the operators such as yourself. Some of the groups that are driving the Open RAN innovation are the O-RAN Alliance and the Telecom Infra Project. The Telecom Infra Project actually takes specifications from O-RAN Alliance and implement them as a project of their own. So here is a very quick chart of defining what the Open RAN relationships are. Where you see the Cloud RAN, where you see the vRAN, and where you see Open RAN. And one of the things you will notice that Open RAN does not need to be software-based. It needs to have open interfaces. Although most of the implementations we see are based upon fully virtualized components, which is actually one of the tenets as defined by the O-RAN Alliance. Right? So the Key tenets of Open RAN are, of course, it's the use of open interfaces and architectures, fully virtualized components, as we talked about, which and an artificially intelligence assisted smart RAN. So the fourth evolution that's coming beyond Open RAN is the AI RAN, which we'll probably see in late 2025 or 2026 as we converge Open RAN, Cloud RAN, vRAN assisted with AI. The second key tenet is to minimize the proprietary hardware and more use of COTS software. And the third, of course, is to define and drive standardization and adoption of APIs, which is basically means that you are putting the microservices in your containerized CRAN. The two concepts that drive both the Cloud RAN and the Open RAN are RAN disaggregation and decomposition, right? So the disaggregation, we have been talking about it for quite a while. You decoupling of the RAN software from the hardware so that you can deploy the software on COTS. The decomposition is something that makes that disaggregation a lot more easier. So instead of decoupling a large monolithic software, like a VM, you decompose your RAN software into multiple components and you virtualize or containerize those components instead of a large monolithic container. The two components that we break down the RAN software into are the distributed unit, DU, and the CU. The DU, as the name suggests, is more distributed across your entire infrastructure. And it performs all your low-level functions, taking your radio signals, doing the Fourier transforms, and those kind of things. And as you can probably imagine, the DU requires a lot less latency between the radios and the processing. The CU is more used for control plane functions that are not too latency sensitive, so they can be deployed a little further out in your infrastructure. These DU and CU functions can either be co-located or can be spread out across the infrastructure. And because of these new components, we now introduce new network domains, mid-haul and front-haul, which we're going to talk about, in addition to the traditional backhaul. So this is a pictorial depiction of what a traditional cell site would look like and what an Open RAN or a Cloud RAN cell site would look like. As you can see on your left, a traditional cell site is where you have a tower and the radios, and you have a box that sits at the base of the tower and that performs baseband processing called a BBU. Now, this BBU is specialized hardware from a provider, from a vendor. An Open RAN cell site, by contrast, it looks like you have a bare metal hardware, so a COTS server from HPE, Dell, Supermicro, whichever your choice is. And on top of that, you run a containerization software layer like Kubernetes, and then you run your RAN software on top of it, right? So in an Open RAN environment, these cloudified RAN components have open interfaces with the RU. That's the difference between a Cloud RAN and the Open RAN. The placement of the CU and the DU will dictate what your XHAL domains are. So you can place the DU away from the cell site, but somewhat closer. You cannot go too far. I believe the restrictions are 100 microsecond of latency of transport latency between the cell site and the far edge. So that translates into a theoretical maximum of 20 kilometers. In reality, it's about 10 to 15 kilometers. Then you can place the CU at the near edge, and then you can have the mobile core in your central or regional DCs. Or you can co-locate the DU and the CU at your far edge DC to do the processing there and have your traffic backhauled into the 5G core. or you can place the DU at the cell site, which is majority of the deployments today as well. And then you use the mid-haul infrastructure between the cell site and the edge DC to provide the control plane functions at the CU, and then you backhaul the traffic there. Or you can use the traditional architecture where both the DU and CU are co-located at a cell site. All those are valid. What we are seeing more and more is basically option number 1 and 3 are the ones that are most typically deployed. All right, why is Open RAN so challenging? Why are we talking still about this? As you can imagine, the first difference is now that you are using open interfaces, there's a lot more that goes into the planning, designing, deploying, validating, as well as operating of that infrastructure. So when you move from proprietary to the open, there's a lot of complexity that comes in terms of integration, in terms of testing. In the legacy RAN, you have specialized hardware. The hardware is specially designed to perform those functions. In Open RAN or Cloud RAN even, in a lot of cases, you are deploying on COTS hardware, so your hardware is generic, from which you are expecting the performance that you were expecting from a specialized hardware. So that's a big challenge and a big consideration. In the legacy RAN, you have a limited supplier selection. Your vendor provides you with the radios and the BBUs, maybe even the network infrastructure as well in some cases. So it is a pre-tested, pre-validated, pre-integrated stack that you get. In Open RAN, now you have multiple suppliers. You have a supplier of the hardware, the supplier for your CaaS or container as a service platform, and the supplier for the RAN. So you have an expanding supplier option, and if you're doing a dual vendor strategy, you now have to handle twice, 3 times, 4 times, maybe even sometimes 5 or 6 times the number of the vendors that you were dealing with in the legacy RAN. And with that comes the challenge of integration. So you do not require your scenario-specific integration as much in the legacy RAN as you require it in the Open RAN. And of course, the lifecycle management. So in your traditional RAN, you're dealing with the lifecycle of a single hardware product. In Open RAN or Cloud RAN, you're dealing with the lifecycle management of the COTS hardware, the BIOS, the firmware, and the drivers and those things, the Kubernetes software that runs on top of that, and then the RAN software that runs on top of that. So it's a 3-layer stack at least. So these are some of the challenges, and what we're going to talk about is what we have learned in dealing with the telcos to deal with some of the challenges. The first lesson that I want to share with you, choose your technology partners wisely. Now, it's common sense, of course, but what does it mean in the context of Open RAN? Now you are not just looking at the RAN software only or the RAN technology only. You have to have a decision to make on the hardware vendor that you're going to use for COTS, as well as the cloud software that you're going to use. Right? So for the hardware, you are looking to get quality hardware to provide RAN signal processing. Now remember, I talked about the Fourier transform and the baseband processing and all the low-level functions that the DU needs to do. A regular CPU-based COTS hardware cannot do that. So you have to supplement that COTS, the hardware, with a hardware accelerator such as the Intel ACC cards. You can use Intel cards, which uses a look-aside technology, or you can use a new and upcoming, which Intel is also doing, I believe, the straight-through processing by the Mellanox and the Qualcomm cards. Right? These RAN nodes are supposed to be placed in harsh environments sometimes, at cell sites, outdoors, and so on and so forth. So you need to worry about the hardening and remote management of the hardware as well. both the hardware and the software. The other thing that you don't have to worry about in traditional RAN is the cloud software. Right? Because containerization is a key part of Open RAN and Cloud RAN, you have to talk about what cloud software you're going to use. Kubernetes in the recent years has emerged as the technology of choice for container management, but you have to probably look beyond just the RAN software to have a Kubernetes platform. You should be looking at the placement of the Kubernetes function, but also that your Kubernetes layer that you are putting in RAN should be able to adapt to other parts of the network as well. You don't want in your organization to run a separate NOC for RAN or a separate technology for RAN and a separate technology for the IT and the 5G core. So whatever CAS software or Kubernetes software you choose for the RAN, make sure it can handle the other domains of your network as well. Whether it's multi-access edge compute or the 5G core or the RIC or the rest of your infrastructure. So that's the first thing. Choose your technology vendors correctly. Second is, remember we have been talking about this. You will need to do a lot of integration, or you will need to work with the vendors to do a lot of integration, in which you kind of need a system integrator. Using a system integrator does not necessarily mean that you will solve all your problems. You will still have to develop in-house expertise and skill, whether you are using the SI or not. Why? Because traditional RAN has been a closed system. You used to get a pre-integrated, pre-validated stack. By contrast, Open RAN is just that, open. So you have to develop those internal competencies to be able to navigate the Open RAN landscape. The SI may be able to help with operationalizing the hardware, software, and the cloud technology, but you as an operator will have to put your thumb on the scale and make those vendors talk, because vendors don't like talking to other vendors in a lot of competitive scenarios. So you will have to bring them to the table and make them talk. I've been in projects where an operator would put all the vendors in a room and make them talk. That's the way to do it. That's the only way to do it. So from an operator perspective, it may require some skill uplift on your side, which your RAN team may not have the expertise for, but you plan for that. One more reason to make sure that you develop in-house skills is because once you do the integration and testing and you deploy things in the field, you need to maintain that SI knowledge to do ongoing LCM. So it's imperative that you develop these skills in-house. Third thing, and to be honest, it's a really common sense: test, retest, and test again. We all do that. I'm going to talk about how to do that or what to do in context of Open RAN in this case. What you need to plan for is a multidisciplinary, multifaceted, your scenario specific testing. You are not testing a physical box anymore. You're not testing a physical network function. You are actually testing the Open RAN solution. So plan for testing the solution and not the box and or a specific feature. What does that mean? That means that, of course, you're going to do the RAN functional test, but outside of the RAN functional test, you also need to test the containerization functions. How do you manage the containerized software? How do you test the Kubernetes layer? As well as what things you need to do in the network to support Open RAN. When you move from a legacy RAN to a cloud or the Open RAN, you lose certain benefits of a closed proprietary system. One of those is the issue of timing and synchronization between the radio and your processing piece. Because it was a closed system in the past, the processor, the BBU, would provide timing and synchronization to the radios. Now, these are two different vendors. You are using open communication between them. The radios need to be synchronized separately than your BBUs, the DU and the CU. So you need to accommodate for that network level, for example, PTP and sync-E testing to your components. The second piece is deployment. Deploying a PNF or a physical box is easy. You put it in place, they have a ZTP, you have a ZTP from the same vendor, things are done. But now you're placing COTS software on which you have to deploy Kubernetes software, the COTS and the Kubernetes software, and then you have to deploy the RAN software on top of it. So plan for an agile, efficient deployment. And one of the things that we have seen is to use an automated GitOps sort of a pipeline is a lot more easier in these environments. We touched on the LCM already, but now you don't have to deal with a box level LCM. You have to deal with the firmware updates, the BIOS, the hardware drivers, and so on and so forth. And on top of that, you still have to deal with the LCM of Kubernetes, for example. There are 2 releases a year from Google. How do you manage that? How do you make sure your RAN software stays in sync with your Kubernetes hardware, with your Kubernetes software? So, if you upgrade your Kubernetes software, do you need to upgrade your RAN? These are some of the discussions that you need to do when you choose your technology vendors and put them in the same room. Reliability and high availability is a concept that's very near and dear to all our hearts. We know about 5 nines and all that, but in an Open RAN environment, you're not just looking at dual power supply or dual supervisor cards and this and that. You're looking at reliability and high availability from a solution perspective. So the radio frequency spectrum, as well as the cloud software, as well as the RAN. Right? So the old debate of pet versus kettle fits in here because in a lot of cases, you deal with a failure in the field by a redeployment. So plan for that, and we're going to talk about that in a minute. I want to extend a little bit on the automated pipelines, which I talked about, that it's a lesson that we have learned, that it is one of the best tools for managing a large Open RAN infrastructure. I think I don't need to tell you guys that as you move closer to the edge and access, the number of nodes grow and grow exponentially. You may have a handful of regional and national sites, 6, 8, 10, 13, 15 is the DCs that you typically have. When you go to the edge and far edge, this number may be in dozens or hundreds. But when you go on to the cell sites, these numbers is in tens of thousands, if not hundreds of thousands. I think Verizon, AT&T, and T-Mobile each have somewhere around 70,000 to 100,000 sites. You guys would know it better. In India, some operators have up to 150,000 sites. So scale becomes really critical, and managing that scale is a gargantuan task. How do you do it? You do it through GitOps. What you would want to do is you would want to define your infrastructure as code in some place, for example, a Git repository. You define the desired state. You put in a reconciliation engine that keeps on looking at the desired state and reconcile your current state with the desired state. So if you want to deploy a new cell site, you add the manifests of the cell sites on your Git repository. You let your reconciliation engine deploy the site, configure it, and make it operational. If you have to push the policies to all 70,000 of your sites, you push a policy on the Git repository. You allow your reconciliation engine to pick up that change from the Git repository and deploy it in the field, so that you are always syncing up the desired state with the current state. This also gives you a single source of truth in terms of your infrastructure as the desired state. Easier said than done, but we have it deployed in the field today in many places. So this is what this infrastructure as code and scaling with GitOps looks like. You would put in a Kubernetes cluster management with the link to Git repository, and then you deploy your infrastructure as you see fit. Another thing that came up very recently in one of our conversation with an operator, concurrency does not equate to scale. We all know we need scale to manage, but we also need the concurrency. Scale is how many sites can you support total overall. Concurrency is how many operations that can be simultaneously performed on that infrastructure. Right? And concurrency is key in an open RAN type of an environment. Imagine if you have a CVE, for example, and you have to patch your Kubernetes software. Now you have to update 70,000, 75,000 sites in a matter of night. Right? So you need to be able to have some sort of a hierarchical management approach where you can provide both concurrency of operation as well as scale. How do you do it? You do it by dividing your Open RAN infrastructure in regions. And you can have a regional Kubernetes management hub that can deploy the software and that directly manages each of the sites. And then you have a global, call it the hub of hubs, for example, which manages each of the regional hubs. So you are dividing and conquering your network scalability in the regions. One of the operators that we recently worked with, they had continental US divided into 6 regions, each region with up to 3 hubs, and then they had a geo-redundant global hub. So you should divide up your geography based upon the cell site density into different hubs, and then you can manage all of those hubs from a single point of the management from the hub of hubs. One of the other things that you should not forget is XHAL. Now we are talking about sprinkling your network infrastructure with mini DCs, right? So the infrastructure readiness goes beyond just the CNF and Kubernetes. You need to be able to have a network infrastructure that supports Open RAN as well. For example, now you have backhaul, mid-haul, as well as front haul. Each of the domains have different requirements. Each of the domains have different things that you're going to put in there. The far edge and near edge DCs, in which you're going to either place the DU pooling or the CUs, are now going to be sprinkled across your infrastructure. There are requirements for the front haul. For example, I talked about 100 microsecond or less. And then you have other requirements as well, such as the real estate and power and cooling. We all know that cell sites could be in a remote location. So you need to be able to provide adequate real estate, power, cooling, and fiber infrastructure to be able to host the cloud platform as well as the software that goes on top of it. And I believe I've already discussed or touched upon the need for technologies such as the PTP and Thinky that needs to be transported across your infrastructure as well. One more thing that recently came up as early as last month is the use of a common ticketing system between the vendors. Now, because you are putting in multiple vendors, such as the hardware vendor, the CAS vendor, the RAN software, the system integrator, and in some cases you are doubling them up, it's very easy to get into a scenario where everyone is pointing to the other as the culprit if a problem comes in. So if you are opening up a ticket, you want to have a common ticketing system across vendors. This is something that frankly speaking, up until a few months ago, we have not thought about it, but one of the operators that we worked with came up with this idea that you create a common Jira or Salesforce or whichever way, or the ServiceNow, but you have a ticketing system where if as an operator you open up a ticket, that ticket automatically goes to all relevant parties at once. So they are all able to see the notes, they are all able to see what's happening, instead of you open up a ticket for one component and then you start talking about whose fault is this. So you get all parties on a common ticketing system in one place. It provides you with a common ticket identification. It provides you with real-time updates across multiple vendors, and each of the vendors have the ability to modify, edit, and share the notes. It may require some work up front. It's not gonna. I don't believe there are a lot of solutions which are available right out of the box. It requires some work up front to set it up, but once you set it up, it works flawlessly. I have seen in real time the examples of that. Right? I think this is one of my most important lessons that I've learned over the years. Lesson number 8, plan for failure, not success, which is contrary to what we typically do, right? We plan for success, we plan for things working, and because of that, when things fail, it's a show, right? So plan for failure, what does that mean? That means that you fail fast and you recover quickly. And I cannot stress this more enough. We are coming from a legacy landscape where you had specialized hardware which was put together to perform a certain function. We are replacing that with effectively a computer, right? So think about your Windows machines at home, how often they fail, how often you have to reboot them, so on and so forth. Now, I'm not saying the servers from Dell and HP are like those, but those are general purpose compute, right? They are going to fail a little bit more than specialized hardware. So you plan for that failure, you fail fast, you recover quick. And that does not just mean for the hardware, but for the software as well. Again, pat versus cattle debate. In a lot of cases, what you want to do, if a site fails, you redeploy it, and then you do the root cause analysis afterwards. So you must put your systems in place, your GitOps pipelines, and your CI/CDs to deploy and redeploy as quickly as you can. Right? It's not a new concept, right? You make sure that you can recover the system. The difference is that you are not, in a lot of cases, you're not recovering a system, you're redeploying a system entirely. And this is what a lot of our operators do today. They, in case of a failure, simply re-image the whole site entirely. How? You do a remote wipe of the server, and you have the GitOps pipeline already in place, your reconciliation engine that we talked about, that will take care of it. So a lot of the lessons that we talked about, number 2, 3, 5, and 6, they play a critical role here. This is one of the most important things to do. Do a simple in-time recovery, and then you do a root cause analysis with the logs that you have gathered. Last lesson, you've got the power. You as an operator, you have the power. That's the whole reason why Open RAN is a thing, to be able to provide the vendors, the operators with choices and flexibility. What I've talked about may seem very daunting, but believe me, there's a lot of operators that have deployed it successfully on tens of thousands of sites, and more of them are deploying it every single day. So it seems a daunting task to take over, But if done right, it gives you immense freedom, flexibility, and the power of choice, the choice of the operators that you're going to use. So Open RAN basically is a collection of a build-it-yourself components, the hardware, software, and the CNFs. And then the architecture that goes on top of it for the management, SMO, and so on and so forth. We are not going to touch that. Each of these components is independent, yet integrated in the solution. Because each component is independent, each component is replaceable. So if Broadcom goes on tomorrow and buys somebody else, you can replace the CAS software that you use today with something else. This is a phenomenon that we are seeing a lot, right? So you can start your year one with a stack where you have a bare metal vendor A, your CAS vendor A, and your RAN vendor A. And in 2 years, and this is a real lesson from a service provider who's doing it now, you realize that the CAS software, your needs for the software, the CAS software has grown to a point where you need something else. You don't need to change your bare metal hardware. You don't need to change your RAN software. You remove the CAS layer, you put the new CAS layer in. This is happening today. This is not future. 5 years down the line, you see new hardware coming out. You want to use ARM. You want to use the AMD processors instead of Intel's. All your choice. You can replace or you can augment your existing infrastructure with the new type of the hardware, whether it's a progression of your existing hardware or a completely brand new path like ARM, for example. And you use the same CAS software and you use the same RAN software. So you have the power and flexibility to do all of that. Right? So with that said, to summarize, I'm going to go through these one more time, and then we're going to open it for the Q&A. Number one, choose your technology providers wisely. That is very important. You should not be choosing for just RAN. You should be choosing for a horizontal telco where you can put your hardware, software, and CAS across your infrastructure. You don't want to be training multiple teams on multiple technologies like CAS and so on. SI's role is critical, but you cannot be hands-off. You have to stay involved. Test, retest, and test again to your specifications. And then scale is critical, and to manage the scale at RAN at tens of thousands, sometimes hundreds of thousands of sites, GitOps is one of the methodology that you can use to scale your Open RAN infrastructure. Lesson number 5, concurrency and scale are different. Plan for scale, but look for concurrency as well. You may require to upgrade 30,000, 40,000, 50,000 sites in one maintenance window sometimes. So plan for that. Lesson number 6 is make sure your network is ready to transition from backhaul to X-haul, which is the front haul and the mid haul. Lesson number 7, which can save you a lot of grief, a common ticketing system to smooth out the communications. And then plan for failure, not success. Fail fast, fail often, recover quick. And because of all of these things, you have the power to influence, to wield more influence over the infrastructure that you have, which gives you a lot more flexibility and a choosing power over the vendors. With that said, questions?
Alex, do we have anything from the online community? No.
Nope.
Anything from the... Come up to the mic, please, sir.
How's it going? Thanks for the talk. I'm Ryan Gonzalez. I'm with Iron Systems, Inc. I was just wondering, based on changing technology and upgrades and everything, what's kind of a standard life cycle for like metal hardware in the industry these days?
Excellent question. So based upon, so what is the life cycle. Now, as we talked about, there are multiple components, right? You have hardware, CAS software, and RAM software. You have to look at the life cycle for each one of them. I'm working with vendors, with operators who have the hardware from 6-7 years ago. They are still deploying that, but also looking at new hardware. So the hardware but the old hardware will stay in, but as it fails, they're going to replace it with new hardware. They are not going to do a rip and replace. So 4 or 5 years easily has been going on, and the new ones, so this is one of the things, the new sites are going to be on the newer hardware as it comes along. CAS software is a little bit more interesting. Typically, you get 2 releases of Kubernetes a year. And in a lot of cases, there are APIs that get deprecated, that get added, removed, so on and so forth. And we know we look at a long life cycle in telcos, but cloud native moves at a different pace than telcos, and telcos are starting to catch up. What some of the Kubernetes vendors are doing, the Kubernetes distributions are doing, is providing 2 to 3 years of life cycle with a support exception for them. So 2 to 3 years is becoming a new norm for the Kubernetes layer itself. But then, of course, if you are upgrading your Kubernetes software, you also have to work with the CNF. So that's where the interoperability and integration comes in. Does that answer your question? You have to look at it as a solution, not just a single component.
Yeah, thank you. And you kind of mentioned that some telcos are changing hardware as something breaks. They're redeploying new technology. So is there interoperability between different vendors for the actual physical hardware itself? Are they deploying something from the same vendor?
No, so
they're not doing, or are they doing a full refresh?
So the interoperability question would come in if you're changing the technology, the underlying hardware technology entirely. So if you move from Intel x86 to AMD, for example, or ARM, that's a different level of interoperability. So they are not doing that. Think of it as so the previous version is the Ice Lake, for example. Now they're looking at Cascade Lakes, or I may be mixing up my names here. But if it's a newer generation of the CPU, you'll have to do some integration work. And those integration work, the CAS vendor, the RAN vendors, and the hardware guys, they do that. That work happens like 5-6 years before those things hit the market. So when it hits the market, not entirely, but yes, there is integration work that needs to be done.
Gotcha. Appreciate it.
Thank you. Anything else?
Anything from the in-person community? Alex? Excellent.
That's it. Thank you very much for having me here.
Thank you, Keshav.
Thank you for the opportunity. Right.